Hey guys, it's AC Coder here, and this time I'm going to be explaining about queue in C++. So in this video you will learn about the queue definition, queue library in C++, implementation in C++, and also solving problems using queue. Okay, so when you ask someone about queue, they would probably picture something like this. Maybe you're queuing for your food or for your ticket. That's queuing in our daily life. So what about queue in computer science? In computer science, queue is a data structure designed to operate in a first in, first out context. This means that the first element that is inserted will be deleted first, similar to how the front person in a queue will get their order first. In C++, there is already a queue library installed in this STL library, so you don't really need to make it yourself, and you can just use their library. So now we are going to see what we can do with the queue in C++. So if you want to use the queue library, you must include queue in the header. When you want to declare a new queue, you can write queue, the type of variable you want, and the name of the variable. In this case, I'm using queue string of hotdog. Next, if you want to insert an element, we can do hotdog.push and the element that you want to insert. In this case, we want to insert two people in the queue, which is Bob and Alex. That's why we push Bob and we push Alex. Next, we want to ask the front customer. We can do this by writing hotdog.front. Then, if the front customer gets out of the queue, we can put hotdog.pop. If you want to count the number of people in the queue, we can use hotdog.size. And if you want to check if the queue is empty, we can use hotdog.empty. So let's see a quick simulation. So first we declare the queue, and two people come in, which is Bob and Alex. Next we ask the front customer, which is now Bob. Then the front customer gets out of the queue, which means that now Bob is out of the queue and Alex is at the front. And if you want to count the number of people in the queue, that means it is only one because it's only Alex left. And if you ask if is the queue empty, we can say it's false because there's still one person in the queue. Okay, so we are going to see how we can implement this in C++. Okay, so first of all, I would like to point out that instead of using include queue, you could use the all-in-one include bits @stdc++.h. So what this does is it includes not only queues but also stacks and also IOStream. So it is all in this include library. So this is actually a pretty handy and efficient way to write it. So I've written down pretty much similar to what is shown in the presentation, so I'm just going to do a quick recap. So first of all, we declare the queue name, and then we push Bob and Alex, and we will print the front of the queue, and then we will pop the queue, and then we will ask the size of the queue, and we will check if the queue is empty. If it is empty, it will return true, else it will return false. So let's try compiling this program. So as expected, the output is Bob for the front here, 1 for the size, and false for the empty, just as the simulation suggests. Now let's try a problem. This time the problem is taken from Kattis ferryloading4. Feel free to try it, link will be down in the description below. So, the simplified statement is as the following. There is a ferry that will travel continuously back and forth between opposite banks of a river, starting from the left. There are queues of cars waiting in two sides of the banks, one on the left and one on the right. It is given their position, which is either left or right, and their length. The ferry will carry cars to the other side with a maximum capacity of L meters in total. Once the cars arrive at the other side, they will leave the area. The question is, what is the minimum number of times the ferry should cross the river until all the cars are carried? So let's see the example on the right here. So the L is 20 meters, which means it is 2000 centimeters. And 4 here is the number of cars. And these are the lengths and the positions, respectively. Note that you should put in the cars in order. So in this case, it's 380, 720, and 1040. Okay, so in this case, what's the answer? So in this case, the ferry will start from the left. The ferry can carry 380 and 720. 1040 cannot be carried anymore because then the total will exceed the maximum capacity. Then the ferry will be at the right. So this time it will carry the 1340 to the left. And finally, 1040 will be carried to the right. So the total number of times the ferry crossed the river is 3. So how can we solve this problem? First of all, let's make some observations. So first, this is a simulation of 2 queues. Second observation, we want to take as much as possible cars because we want to find the minimum number of times the ferry should go back and forth. Third, when we want to take the left side of the queue, the right side of the queue does not matter. Because when the ferry is at the left, the right side of the queue cannot be taken. And similarly, if it's on the right, the left side cannot be taken. So we can independently find the number of times the left will be finished and the number of times the right will be finished. In this case, the left side will finish 2 times. The first is taking 380 and 720, the second time taking 1040. And the right side will only be finished after 1 time, which is only taking 1340. So in this case, it's true that the answer is 2 plus 1, which is 3. But you might be thinking this is not the final answer because, for example, we need 5 times from the left and only 1 time from the right. We cannot just take 5 plus 1 as the answer because we need to go back and forth, back and forth, back and forth, which means we need to take 9 times. So now let's say the number of times the left queue will be finished is x, and the number of times the right queue will be finished is y. And we know that the ferry starts from the left. So let us consider if x is greater than y. If x is greater than y, the right side will finish first. So let's say in this case 3 and 1. So first of all, we go from left to right, which means x is 2, and we go back from right to left. Now y is equal to 0. See how the x is still 2, meanwhile the y is already 0, which means it's finished. So the right side will always finish first, which means we really need to only think when the left side is finished. So we need 3 trips to finish the x. And notice how we need to fill in x minus 1 gaps in between, because we know that the ship must travel back and forth starting from the left. So in this case, it must be 5. Generally, it must be 2x minus 1. Now if x is smaller than or equal to y, then the left side will finish first, which means we really need to only think when the right side is finished. We know that we need 3 times from right to left, but we know that the ship starts from the left and it must go back and forth. So we must fill in the gaps, which is y in total. So in total there would be 6 times trip, and generally it would take 2y trips. So let's quickly implement this in C++. So first of all, I would like to show you the input format. So this is a multiple test case question. So in this case, if the test case is 4, that means there will be 4 test cases given. So we must input 4 answers. So that is why I'm going to cin into test case and loop test case number of times and to call the function solve. So in this function solve, we only need to care about one of the test case. Okay, so let's see. So the first, it is given the length and then the m, which is the number of cars. So let's make integer lm, and we're gonna insert it into the variables, and then we are going to loop it n number of times. Okay, so we need 2 queues of integer. The first queue is queue left, the second queue is queue right. Okay, so the input is the length and then the position. So we must have variable length, and we must have the position. So we cin, and now you should check if position is equal to left. We must insert length into the queue of left. Left dot push length, else right dot push length. Okay, now that we have input the problem, we will solve it using the way I've shown in the presentation. So first of all, we're going to loop until the queue is empty. We should first check the left one. So while left is not empty, okay, and we should store the answer here is equal to 0, answer 1. Okay, next, every time you want to take as much as possible. So first of all, we need to do another while loop. Now this time we still need to check if the left is not empty, because if the queue is empty and we want to take the top, it will be a runtime error, so we don't want that. So next we want to make variable integer temp is equal to 0. So this is the current capacity, and if the current capacity plus the top of the queue is lesser than or equal to L times 100, that means you can still take it. I mean front. That means you can still take it. So temp, you will take the front and then you will pop. Now if you cannot take it anymore, you must break. Okay, and once that all of that is done, what we need to do is add 1 to the answer. Okay, so we're done with the left part. What we need to do is just copy and change it into right. Okay, once we got answer 1 and answer 2, we check if answer 1 is smaller than answer 2. That means we can, no, if answer 1 is greater than answer 2, we must see out 2 times answer 1 minus 1. Else we must see out 2 times answer 2 and line. Okay, so let's try it. Okay, as you can see, it's 3, 3, 5, 6, which is correct. So let's try submitting it. So we got accepted. Okay, thank you guys for watching. If you like this video, please consider hitting the like button and subscribe. See you guys on the next video.